Sorry. So we're moving on to logarithmic equations, solving log equations. These are, of course, equations that have variables inside the argument of a log. If they're not in the log, then they're just a regular equation and it's log of some number, right? So for instance, log base 2 of x equals -3. Or this one, ln of x minus ln of x minus 4 equals ln of 3. And this is why we had all that stuff in 6.5 where we talked about the properties of logarithms, because they're going to help us solve these. All right, so the first strategy here is the property of logarithmic equality, which is so long as our arguments are greater than 0 and our base is greater than 0 and not equal to 1, if we have two logs with the same bases and they're equal, then the arguments must be equal. So log base m of n, log base b of m equals log base b of n implies or forces m to equal n. So for example, if I've got log of x equals log of 8, then I know x has got to equal 8, right? Because all I have here is logs. There's nothing else in the equation, no scalars in front of our logs, whatever, but note that the bases have to be the same. So here I've got ln, there's nothing else, so I know x minus 4 has got to equal 5, x has got to equal 9. Now that's not going to work for my first two examples though. So that one's pretty easy, right? So what we can do, we really need to get the variable out of the exponent, out of the log. Sorry, I said the wrong thing. So to do this, we can try a couple of things. One is, or the most common, is to combine the expression to a single log and then rewrite as an exponential. If you can't get it to a single log, if you can get it to two logs and nothing else, you can use the log equality property. So, but you do need to make sure that your solution is in the domain. Okay, so no negative values, things like that. All right. So for example, so here was one of our ones, right? We had log base 2 of x equals -3. So we'll go back. This one is, we've got a single log, so we can rewrite this one really quickly as an exponential. So rewrite as exponential. And then we know what x is equal to, right? What is 2 to the -3? That is 1/8. And all we've got to make sure is 1/8 in the domain for logarithm. So we remember what logs look like, right? The graph of the log goes like that. And its domain is all positive numbers. So yes, 1/8 is in the domain. All right, so same kind of story here. We've got ln of x equals -2. So we could rewrite this as an exponential. E, right, our base, to the answer equals the argument, right? What power do I have to raise e2 to get x? Apparently the answer is 2. So e to the -2 equals x. And that's a very good place to leave that answer. That is 1 over e squared. So it's about 1/8, give or take. So is 1 over e squared in the domain? Again, it's greater than 1. So 1 over e squared is greater than 0. So yes, we're good there. All right, so a little more complicated here, but first we note that our bases are the same. And while we have more than one log, so we can't directly rewrite it as an exponential, we can combine these two logs into one, right? Because we can use the multiplication property or the product rule. So we can say that these two together would be the log of the product, x plus 1, x minus 1, and that's equal to 3. And then, so we'll say combine with product rule, right? And then we're going to rewrite as a log. As exponential. I keep saying the wrong thing. So 2 to the output equals the argument, x plus 1, x minus 1. Now this is a quadratic, right? 2 to the third is 8. And this is x squared minus 1. So I've got x squared equals 9 and x equals plus or minus 3. I'm going to rewrite that the other way. X equals plus 3 and minus 3. Now, plus 3, that one's fine, right? That would be log base 2 of 4 plus log base 2 of 2. Those are all fine to do. But if I try to plug in negative 3, I would have negative 3 plus 1 is negative 2. And negative 3 minus 1 is negative 4. Those are not in the domain of logs. So this negative 3 is not in the domain. We have to throw it out. All right. And again, you can check your answers by graphing. And so we've hit 5 minutes, so we're going to stop and chunk into another video.